Good day, my dear postgraduate students. I would welcome you people to kindly appreciate what you can identify from the screen. Also, I would be immensely happy if you can compare and contrast this picture with the eventually oncoming pictures that are going to bewilder us. The class for today is Automation in Histopathology, and the component I shall be dealing with is histokinette. This has been a repeatedly asked university question, and even otherwise, it will hamper us a lot if we do not answer this fluently in our viva at the practicals. There is something called as manual processing. This particular slide I have put up just to recapitulate the various stages by which the tissue processing goes through. Also, what are the various stations that are there? This is conventional and almost constant. So this list I will not be reading again. You are supposed to be very familiar. Each of this is a notion by itself. And there are the various grades of alcohol, then the clearing agents that are available such as xylene, the molten paraffin, and ultimately there will be something called as embedding, followed by a section cutting. And all this is called manual processing. Manus means hand. That is what this picture depicts. I would also like you people to kindly appreciate the neat modern histo lab from the Mayo Clinic. It is not very pompous or advanced, but then there is a sense of rhythm in it which I can see, or rather you can see. There is a machine called the histokinette. The processing is going on, after which I find that there is a water bath and other things. A section cutting is going to go on at this station, and probably there is something called the hot and the cold. Probably there will be something called the embedding that will be going on, and finally you get the slide out. So this is a beautiful one. The instrument that we are seeing on the screen is the histokinette. And Culling, the great author of histotechnology, has defined this as the most sincere technician. Why, we shall see. This instrument is somewhat circumferential in appearance, and it has got multiple jars. Some of these jars have got connections for the power supply. Probably they will be having some heaters in it in which molten paraffin can be maintained. The others are, of course, glasswares which have got a reading for the reagents to be added. Here again, there is something that is there for either the alteration of the temperature or the switching on and off. And this one is called the master plate. The master plate is one. You find that there are multiple teeth that have been cut out of this circular plate, which are supposed to indicate the timing. We shall be revisiting it later when you get used to it. This is the classical protocol. It can vary from laboratory to laboratory and also according to the time available. So there are, whatever be the fixation, there is again one stage of fixation followed by the ascending grades of alcohol. This is still followed by the clearing and then maybe 2 or 3 changes of paraffin. In total, there might be about 12 jars that are available. The various stages are again mentioned over here. And look at this one. This again, I would like you people to appreciate. I will be repeating this n number of times so that it percolates your mind. This is called the pivot. The pivot is something that can uplift it. And there will be radiating arms called the levers. And what happens is this can lift the jar that contains the tissue blocks. So the capsules will be within, and I find that they are percolated. So it can change it from one place to another according to the time that is available. Here again, I am seeing the master plate. So this will be niched or notched according to the convenience of the laboratory that is using it. And look at the jars over here. They are somewhat porous, allowing the free flow of fluid from all directions. This is not the tissue capsule. The tissue capsule is over here because this space is too much for even a small fragment of a biopsy, which is well contained within the tissue capsule. And these can be put into it so that they can go from jar to jar for the various stages of processing. I hope this is very clear for you people. This is being manually done by the technician according to the time that is set by the laboratory. So again, a repetition of the same. So let me see this. So I find that there is an umbrella over here which covers the entire thing. Also, there will be a lid that is available. This will be preventing the evaporation of the fluid. Most of them will evaporate. Take it to be alcohol or xylene or whatsoever. They have got a tendency to evaporate. And in order to prevent it, there will be a lid that snugly fits. I won't say tightly fits. And here again is the pivot. Pivot is the central pole that supports the entire thing. There will be the radiating arms which will be carrying the jar to the various containers. And in this case, it is a different format by which it has been programmed. I'm not seeing the master plate, and there is a little bit of sophistication that you can see in this. So this is the histokinette. And why is it called the most sincere technician? Because you close the lab and you go, this fellow will be functioning. And be it a holiday or not, it will continue functioning. And this is the paraffin jar over here. It has got the provision for heating. It is made up of aluminum or an alloy of it. And you find that inside there will be the jar, and the paraffin will be able to pass through and percolate through the tissue capsules, enabling the stage of impregnation. Impregnation is wax goes into the tissue. So this will be containing the various tissue capsules over here, and this is again the modality by which it can be carried. So this is something that we can very clearly understand. Again, a repetition. So thanks to Leica, from which I had taken a good number of pictures. And how is this being processed? You find that initially the first jar, the glass jar, will be formalin, because whether we have fixed the tissue properly or not, the histokinette will not be taking the risk. So there is a refixation for a period in formalin. And then there is a gradual dehydration in ascending grades of alcohol, after which it goes in for clearing in xylene or chloroform, whatever the laboratory might use. After which it is subject to changes in paraffin, which is over here. And the processing is almost full. That is how it comes to. Processing in the sense up to the stage of impregnation. After that, we have got something else. So this is again beautifully explained, this kind of a diagram, very difficult for us to get. So I find that this is the thing covering the multiple lids. Oh, so you find that they are all snugly fit to prevent the evaporation. Centrally, there will be a pivot, and then there will be the radiating arms or the levers that are available. So there is a pivot, there is a lever, then there are the glass jars, jar made up of alloy. Over here, provision for heating, a master plate for controlling the time, which is programmed. There will be a power supply and a time. So these are all important things for us. The basic steps that you're doing in your routine tissue processing is being done at the histopath. So this at least you people are able to see. It is a beautiful picture. I think it will get registered in our mind. Thanks to Springer link. Whereas this fellow is the latest counterpart of Leica itself. In this, I am not able to see the jars. I am not able to see the paraffin. I am not able to see any master plate as such. But then there are a lot of these containers lower down. Of course, these will be the various reagents in that concentration as required. There will be, for example, formalin, 10% formalin. And then there will be the ascending grades of alcohol. Then there will be the xylene, 1, 2, or 3 changes as is required. Then there will be the wax. Wax, of course, is not in this one. It will be up to the clearing agent that is available in all these jars that we are seeing. Fine. And here only you will be having the molten wax, and then there will be a dipper or a tray for which the tissue capsules can be kept. I will be showing a picture of it. And this incidentally happens to be the monitor by which you will be able to control. You are not having the master plate in this case. It is all being computer programmed and controlled. If you cannot understand, again see this. So there can be a slight variation. In this picture, they show that there is a wax bath over here, whereas in our laboratory, it is over here. So there are two things here, and there are the various retorts by which we can be filling them. This is the master screen by which we will be able to manipulate and change. It's a touch screen by which you can operate, just like your cell phone. And these are the various reagent cabinets from which we will see how it goes into the tissue as such. Now, there is a difference. In this case, the tissue will be static in one position, and the reagents will be going and filling it, again getting drained out, and the next reagent goes and fills it. It goes on like that. Whereas the tissue is constant. In the earlier version, we had seen that the tissue moves from one jar to another. Tissue means it is a group of tissues within the capsule. Look at this one again. So these are the various things. This is a beautiful one. Are you able to see the wax over here? There will be the molten wax that is available. So it is separate. And this will be the trough where the various capsules can be put. And I find that these are all the various reagent storing ones. So, and there is an air pump which will be operating it. So this is important. I have just shown xylene as one. We will have to take the precautions about the specificity of the reagent that is required and procure it from a good quality company. We should not compromise with it at all because it will reflect on the processing of the tissue as I will be showing you in a few examples. Look at this one. This is the trough I have been mentioning. And in this, there are a series of capsules over here. And each capsule will be having the tissue within it. It can be a biopsy or part of a specimen whatsoever. And each of those will be numbered and it will be in a form of a paper with pencil. It will not be pen because the ink can be erased by the various reagents. And it is placed in a trough. After having been placed, these are all the various reagent jars. There will be the provision for this material to go into it. They wait for that particular time, 1 hour or so, after which again there is a provision by which it is drained back into the same jar. Then the next one goes in for action. That is how it proceeds. And this, of course, is a molten wax over here. So I would like you people to kindly appreciate these things. The advantages of the histokinette will be, it will be saving time. Obviously, it saves time in the sense the manpower, so on. It works overnight, even on holidays. And there is no manual error. It is not that I'm forgetting to change the solution or so. And there is a neat allotted place where everything fits in. A large number of samples can be simultaneously processed. Whereas in manual one, you find that there will be a limitation of space. Therefore, only in small quantum it can be done. So these are all some of the advantages of the histokinette. Whenever I say advantage, there will be a disadvantage also. For example, the initial cost is going to be exorbitant. It will be running into several lakhs. And here again, we feel that the foreign instruments are better than the Indian instruments because of the precision. And there has to be a maintenance and servicing, which again can be costly. Space, though it is small, some amount of space is required in the laboratory. Programming, therefore, there is a software now, and that has to be programmed well. And we will have to procure the reagents from specific company and not compromise on it. This again can be a little cost oriented. Evaporation can lead to loss of the reagents. And there can be different kind of timing for different specimens, small biopsies, and then a large bit, 1 into 1 centimeter from a soft tissue. You find both cannot be given the same time. Therefore, if you are good enough, we will be having a separate programming for the small biopsies and a separate one for this. But then some laboratories overlook this and do the processing, and sometimes we have to pay the penalty for it. A backup machine will definitely be required because of any of the technical problem. If this machine is going to get shut down, you cannot stop the histoprocessing. We cannot ask them to stop the surgeries in the theater. Everything will be continuing. Therefore, a backup machine is required. And again, the same story of space, cost, etc. And the technicians will be well trained to handle such things. If at all there is a problem, we see the slides and then tell them that there is some mistake in the processing. But it will be difficult to localize unless our mind goes back to the histo lab and goes in a reverse direction to find out where exactly the mistake is. And for this, repeated exposure is needed. And many of us and the technicians might not be aware of the problem, particularly in the newer version of the machine, because nobody, once it is closed, nobody knows what happens. For example, this particular tissue, what are the errors in processing? This is under processed. So there is some kind of a separation. It looks as though there is a fat necrosis that has crept in, which is really not so. So it is being under processed. In some cases, it will be over processed. So all the changes that we see as artifacts can be found over here. So I find that there are some marks over here. So this is shown. And we think it is because of the microtome cutting, whereas it is because of the processing itself. And look at this particular section from the liver. So this particular area is different. This is okay. And this is definitely bad. So the different parts of the same tissue or same bit of tissue is showing different staining and the processing. That is because there is a overheating or some kind of a defect in it. Also, when there is a overheating, there can be a separation of the collagen fibers and so on, which is very well made out in it. And look at this, even the epithelium is not well able to take up the stain. Fracturing. So this generally we see, we call them the zebra lines or the cracks in the tissue. But this can happen because of the embedding also, not necessarily because of section cutting. And damage to the tissue. Obviously, it looks like a massive necrosis to me, but it is not so. It is an artifact. Artifact means we have created it, and it is due to overheating. And this again, overheating in a hot plate in this case. So this again has led to, this is a specimen, I think it's a lymph node or so. There is no business for such spaces to be in a lymph node. It is artifact. And this is the age-old commendable person culling and his histochemical techniques or histopathological techniques, which we people should repeatedly revisit. You can go to Lynch, you can go to Bancroft and culling. Please be revisiting them n number of times. It is worth it. And all of this, I will not be able to locate where exactly the problem is. Is it within the tissue trough, or is it within the wax, or it is because of the various reagents, or is it because of the time set in the monitor? Difficult to locate. The next one is embedding. Embedding is after the impregnation, there is an embedding that is going on. Impregnation is I'm putting it in molten wax and the wax percolates into the tissue. After that, the tissue will be needing a mechanical support so that it can be held on to a microtome and sections can be cut. That is called embedding. This used to be manually done, but nowadays we have got the various capsules. And from this, you pour it according to the size of the tissue. The wax is poured over here, and you get a neat bit of a tissue over here, fit for microtome. And this acts as a block holder as such, when it can be fitted onto a microtome. It is ready for section cutting. And these are the various sections or the paraffin blocks that are ready for sectioning. This I would like you people to leisurely go through. Something that I already explained and what is the history of the histokinette, etc. And going to the 20th or the 18th or 19th centuries, how it came into vogue. And also this. So there are two terms that I would like you people to just observe, dip and dunk. And what is this? I shall be showing you. So this is again one of the latest versions over here. I find that there is a monitor and again a trough will be available. For molten wax, there will be a provision. There are the various reagents. They will be coming in by the tube to the trough holding the tissues, and there will be another tube that is draining it back into the same container. These are not small tubes as they are appearing. They will be elongated almost half or more of the distance of the histokinette. So they are quite huge and voluminous. As technology advances, it reverses the characters of every situation again and again. And the age of automation is going to be the age of do-it-yourself. Nowadays, that is what is happening. Automation and do-it-yourself, probably there is only a hairline difference which we are not able to appreciate. This is a dip and dunk. So in one condition, here I'll be finding that there will be a dipping of the tissue in each and every one, and then it goes on to the next jar. Dunk is, it will be left as it is, and then the reagent is poured onto it. This is a modern enclosed one, and this is the earlier version of the histokinette. I would like you people to kindly write any 6 difference between these two. The pivot and the lever, etc., they are all not over there, and there is no master plate over here. Everything is being controlled by the computer. The tubes are invisible by which it will be going on. And once the reagent is old, there is a red alert that is given. It has to be changed. And look at the modern lab. The concept of it basically, look at the space that is there. And always you find that there are no enclosures. This kind of a design was appreciated by one of my professors, Dr. R.A.T.S, so that if you are going to be in charge of the laboratory, you stand up in one place, you have got an entire vision of the laboratory or vision of the entire laboratory. That's a better word. So there is space. All the gadgets are along the wall. You will be able to move around. And the chairs and tables are all designed with leg spaces. And the machines are this. Look at this one. It is so comfortably placed. It is not looking clumsy at all. Well lit, and there is a provision for 24 hours of water supply and electricity. So the infrastructure, the manpower, the reagents, the regulation for procuring them, disposing them, all these matter a lot. Beautiful. A picture of an art. So I think you people are able to appreciate this picture. Amazing one. And this is exactly what I meant. This is an earlier method of embedding. And these are called the Leuckart's L pieces. L in the sense, when I put both of them together, I get a square-like space or a cubicle in which I am placing the tissue and then pouring the molten wax over it, allowing it to solidify. So this is called as embedding. It is not impregnation, it is embedding. The wax gets solidified and these L pieces can be separated, the wax becomes solid. It is fixed onto the block holder. This is a beautiful one, and personally I feel this has taught us a lot. And look at this fellow over here. These are the L molds, usually made up of brass. Nowadays we are having other alloys such as aluminum and so on. And this is a block. The tissue block is over here that has been prepared from this one, and it is fixed onto the block holder. This will get attached to the micro and sections are being cut. So this will have to change according to the size of the tissue. For example, this is a large tissue. I should not compress it into a small kind of wax, so that I find that there will be a kind of folding and so on. This is a tissue embedding. There is a screen that is over there. I find that there is a molten wax that can come in, and then when I cool it, it gets solidified. But as I said earlier, I feel that manual is always much better. This is again the same. The cold and the warmer. These two stations alone, you people can appreciate in it. But then, in my personal opinion, particularly in smaller laboratories, this is an utter failure. In fact, automation, one of the care that we should take is we should have volumes of material that is there. For a few specimens, I cannot be using a histokinette. There is a wastage of the initial investment, and also there will be a loss of the reagents. So cover slip, this again is one more failure over here. I find that manual is always better, because here again, they are trying to cover each and every slide. But then manual, you will be able to save time. You can find out the error. Air bubbles can be avoided. There is a precision. The hand of the technician, it speaks for itself. And also processes such as dehydration, clearing, everything is well made. It is not a cumbersome job. It is not costly when we do it manually. So I still feel, in my personal opinion, manual as far as the cover slip is there is much better. But then the MCA or the NMC whatsoever, they insist on such machines being available, and these are being procured by the various medical colleges. So kindly see if you are able to identify all this. So there is an umbrella, there is a pivot. I find that there will be the lid over here, and as it moves from station to station, these are being covered. Some are made up of metal for maintaining the molten wax. And this will be the adjustments that can be provided. The age of automation is going to be the age of do-it-yourself. That is what we had seen in an earlier quote also. So this gives an entire summary of the latest histokinette. So look at this over here. There is a monitor and all the other things that we had mentioned. And this is a trough where there can be the molten wax. There will be 3 parts of it, and depending on the amount, it can be either 1 chain, 2, or some institutes insist on 3 changes of wax. And once it is quite old, the first one will be discarded, the other 2 being used. And these are the various monitors, what all you people need, the changes of the timing, etc. can be done, thanks to Leica. Maybe there are other companies over here, but this is my personal experience, and I feel it has stood the test of time. And What is common to all of this? It can be Sysmex, or it can be the Coulter counter, the Leica, any of the embedding machines, robotic surgeries, 3D MRI, telepathology, ELISA, and the making up of the reagents, digitalization. We are all going into a world of automation. And automation is going to be the future that is on the screen. I have already discussed this in one of my classes. Digitalization of the laboratories. What is going to be our future? Sooner or later, the US will face mounting job losses due to advances in automation, artificial intelligence, and robotics. Thank you.